Thomas. I'm technical evangelist for Basho. Used to be an operations engineer. Started using React a lot and really liked it. So I'm kind of here to tell you the quick version of why you should enjoy it, why you should try it. So my name, technical evangelist. You can always reach me, Seth at Basho. If you'd like a legal liability, you can follow me on Twitter. We make two things at Basho right now. We make React. It's open source, distributed key value store. We also make React CS, which is an application built on top of React that allows you to basically create your own S3 clone inside your data center. A lot of people want this for regulatory purposes. They can't put stuff in the cloud, but they want all the semantics, all the S3 tools, S3 command, all that fun stuff. So if you're interested in that, certainly talk about that later. First, we're open source, so yay! We picked an Apache 2 license because we don't like, Apache 2 is one of the licenses I prefer. I'm an MIT BSD kind of person. We also make something that we make money off of, which is React Enterprise. React Enterprise is just a little bit, just a tiny fraction of what React actually does. So for the enterprise version, you pay for support and replication between data centers. This may be replication across the globe. Some of our customers are replicating between 5 different countries, all real time. So the React basics, we're a key value store. That means no columns, no tables, no nothing. You have keys, you have values. It's very, very easy. You can't get a simpler data model. It's just gets, puts, and deletes. And it's really only gets and puts because puts are just, deletes are just puts with a tombstone. So it's really just gets and puts. Sorry about that. And what we do best is scalability. The idea behind React is once you add, you start off with 5 nodes, so it is a bit higher barrier to entry. But you can go from 5 nodes to 180 nodes. I say this because we actually had a customer, Voxer, who went from, they had a nice, modest 10-node cluster, and then a wrapper tweeted about their service, which meant that everyone under the sun came to their service. They were actually adding servers as fast as they could rack them. They got up to 180 servers in about 6 weeks. They've now calmed down and actually balanced it out a lot more. They're about at 85, 90 servers right now. But the idea is that you don't have to think about scaling. They didn't hire any more ops people to do this. They just scaled. That's what we do best. Additionally, fault tolerance. It's great if you have a really, really awesome, sweet, bespoke database machine that has all the redundancy in the world, but what happens when that one machine fails? We start off with 5 nodes. We're a cluster. We're fault tolerant. Your data is replicated 3 times. Nodes will always be available for reads and writes. It doesn't matter what node you talk to. You talk to any node in the cluster, you can read and write data. On top of that, fault tolerance is availability. Again, these nodes will always be up. As long as your entire data center hasn't went out, you can still write data. You may not be able to read data if it's stored on another node, but you'll at least get a response from your database. The database will never just say, sorry, I'm too busy. You may have experienced this with some of your SQL stores. It's like, oh yeah, I've got a queue back here, and I'm just not going to talk to you until I'm done. So that's what we do. I have a slide for questions, but I also have a quick demo to show you how easy this is to scale. So if anyone has any questions right now, I can answer them, or I can just move on to the demo. Demo? OK, cool. Sweet. I ran through that really quickly so I could show the demo. So, OK, this is going to be really hard to do, because I'm going to have to look at the screen here. So, oh, sweet. So this up here, this top window right here, so this is, I have 2 nodes right here on my local machine that have 50% of the data on the cluster. Right here, I have another node. This is the dev3 node, and it's off in its own little cluster all by itself. Then down here, I'm going to tell, oh no, he's already a member of the cluster. I wasn't supposed to do that. This is why you don't set up demos 5 minutes before you do them. Fine, I'll do dev4. Of course, this isn't going to work at all. There we go. That's always fine. Bear with me. It'll look really cool when it works. Let's see. I actually had to turn off my firewall earlier because it was complaining. There we go. So, and now it's already a member of the cluster. All right, so the idea here is you should be able to, as you do this, you'll actually see as you add these nodes in the little demo, the data just slowly migrates out. There's not actually, all you do is you do this, you plan a commit, you commit a node to the cluster, and that's it. There's no setting of your MySQL slaves, your MySQL replication. You just do this from 5 nodes to 180 nodes, super, super easy. If somebody wants to see the demo working, I'm not going to try and make it work and fail again. Because this is totally a beta build that I whipped up right now. But if anyone has any questions, let's go ahead and do those now because the demo's totally blown. Oh, yes.
So if you have 180 nodes, how well does that deal with concurrency and quick updates?
It's built to do that. We're actually written in Erlang, so we're extremely high concurrency. Every node that you talk to can service any requests, so you just throw a nice load balancer in front of it, and concurrency is not a problem. We also do, if you're talking about conflicting updates, that's something we actually deal with particularly well. Most of your databases will punt into a last write wins strategy, so if you have a conflicting update at the same time on 2 different nodes, normally with your, say if you have MySQL master, you have to resolve that manually. React actually will store what we call siblings of your object, so instead of just saying, oh, whoever had the best timestamp wins, we will actually store all of the objects that were supposed to be written in that time where nodes couldn't communicate with each other quickly, bubble up to your application logic, and you actually resolve it yourself. We also have a few data types that have a lot of cool math behind them called CRDTs that actually do that for you automatically. Counters, sets, and maps that you can just throw data at and they will automatically resolve on the correct value without you having to do a thing. Yes?
And that works with the enterprise product with multi-site DC?
Yes. Yes, everything that works in React also works with the multi-DC except for one of our brand new features, which is called strong consistency. Yeah? No, so we offer for the site-to-site, we have a full sync as well as a real-time. So we actually report if your real-time is backing up for whatever reason, your WAN link is flapping, you can totally just wait until, if you can wait or report on that and then do a full sync. Your WAN speed will definitely affect it, but if you have if you have enough money to have the pipes to do a multi-DC hop, it's usually not going to be a problem. We're talking under like 20, 30 milliseconds if you've got a good pipe easily. Some of our customers are actually pushing sub-millisecond, but they also have more money than we'll ever see in our lifetime. So, yeah.
Besides the ease to scale, what's the benefits of this over Mongo?
So Mongo falls over when you scale it. That's kind of where we actually that's where we do our best. Mongo they have a great blog post. It's like 100 gigabytes is big data. We have customers storing hundreds, if not thousands of petabytes right now, and that's where it actually becomes an ease. So with Mongo, you actually have 3 different failure domains. You have replica servers, config servers, and data servers. With React, every server is the same. There's no special roles, and so you don't create, I use the term lots of little failure domains. You don't have any of those. If you lose a server, we expect it to go down, and that's just a given. So there's not as much, see the word I want to use, especially with like MySQL's master-slave setups, there's a lack of brittleness. It's kind of baked into it. Now the threshold that you get, to be fair, is Mongo is going to be really easy to start up with on your one node. React, for you to get really any advantage, you're going to have to start off with 5. So that is a kind of a threshold. We see a lot of customers start with Mongo, hit scaling problems, come to us. We aren't document model though, so you have to denormalize your data. But boom, perfect. I'm going to have to punt on this one then. Okay, go ahead. We'll do it.
So it sounded, when you were speaking earlier, it sounded as if you had an issue with nodes went down that you could still write but not read.
So yes, so potentially.
Probably using something similar to software transactional memory.
So when I say you can't read, you may not, in the case of a network partition where you can't reach one of the replicas that has your data, then you can't hit. That's what would happen.
The question is actually separate. So when you can write, because nodes are down but can't read, where are you writing to?
Whichever nodes are up.
Okay.
Whichever, so.
And that just keeps and waits until the other nodes come up and then we'll
Correct. So what we do is we create these what we call fallback nodes. So anytime the nodes, they can't see each other, they detect that they can't see each other and spin up all the fallback nodes on, so if you had a crazy failure with five nodes and each one couldn't see each other one, each one would start to build out replicas for all of the others until everything sorted itself out. So it would preserve all those writes, and then your conflict strategy would depend on whether you chose last write wins, relying on vector clocks to resolve it, or you used a data type that automatically resolves it.